So fundamentally, the build-up or the construction of fiber is pretty similar from one to the next as a traditional fiber, and I'll talk about why I mentioned that in a second. But Cleerline fiber is slightly different. But what you have here is the fundamentals of fiber. At the very center, you've got that 9 or 50 micron glass core. All right, so that's a core which is 9 or 51 millionths of a meter in diameter. All right, tiny, 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 tiny. Around that, you've got that 125 micron cladding, or that mirror, that stops the light from bouncing out to space. It creates a kind of a refractive barrier that causes the light to bounce down the core instead of out to space. And then you've got different layers above that. The first one being a kind of a primary and secondary coating. You've got an acrylate, as they call it, which is a hard acrylate which goes around the cladding. And then you have what they call a buffer jacket, okay? And then above that, you've got some Kevlar strengthening fibers, and then you've got the actual jacket itself, the outer jacket itself. So you've got these various layers. With any traditional fiber optic cable, you've got these various layers, and you have to strip each of them back. You use those strengthening fibers to pull the fiber. That gives it the tensile strength. And then you've got to strip back that buffer jacket and the acrylate using specially calibrated fiber strippers to a very specific length, leaving just enough of the cladding exposed that it's suitable for the connector you're terminating into. You have to clean the cladding with special alcohol wipes. You have to be very, very careful not to poke yourself. When you've stripped all those different layers back, the core and cladding, being 125 microns, is literally the size of a hair. It's like a glass splinter. All right, so if you were to poke yourself with it, it could actually puncture your skin and break off into your bloodstream and cause problems. Okay. So fiber optic, not only is it very fragile, but it also takes a lot of preparation time, and it can potentially be dangerous if you're not properly certified in how to handle it. So let's talk about how we've overcome all those problems. All right, Cleerline's slogan there is Cleerline SSF. All right, stronger, safer, and faster. It's quicker to terminate than regular fiber. And the way we do it is this: we've still got that glass core. All right, and that core is 9 or 50 microns in diameter, depending on single mode or multi-mode. And we've still got a cladding around that core, but we actually reduce the cladding down by 10 microns and build it back up with that SSF polymer that we call it, stronger, safer, faster polymer. Okay, so our overall size beneath the acrylate is still 125 microns. That's very important to remember, because it makes our fiber compatible with anybody else's fiber, anybody else's connectors, anybody else's tooling and termination equipment. Okay, this is not a proprietary system. The only proprietary nature of what we're looking at is the polymer that protects our glass and makes it very, very strong, safe, and easy to terminate. All right, that never gets taken off the glass. Okay, so what you'll notice here is the first obvious difference here is that we don't require that 900 micron buffer jacket. All right, that 900 micron, or basically a millimeter jacket, is there for protection of the acrylate and the glass underneath it. All right, we don't need that because our protection is provided by our polymer. Beneath that, you've got a 250 micron acrylate, which is a hard acrylate. You have to use calibrated fiber strippers to strip that off with a conventional fiber. Our fiber underneath is strong enough that we were able to develop a soft peel acrylate that you can literally peel off between your finger and thumb. So what we've done here is we've reduced the amount of tooling that you need. We've reduced the amount of training that you need for preparation of terminating. And we've also increased an element of safety and strength to the fiber that doesn't require the extensive training that you would normally have to use. So with that, I'm going to hand the camera over to Stephen, and he's going to give you a live demonstration of some of those parts and pieces which I just explained.
Good morning, gentlemen. So, as Gary mentioned, when we talk stronger, safer, faster, one of the big aspects is on the safe side. This is something you would never, ever do with a traditional fiber. One of the other things, if you guys have ever seen my demo, you can actually tie it in a knot and we're not breaking that fiber. I can actually rip the jacket off and not break the fiber also. So that's one of the big advantages, is just the pure strength. Now, best practices are, you always want to pull from the Kevlar. The 225 pounds of pull strength that we have is all due to this. So, let's turn the camera down here. You guys can actually see a termination. So the first thing that you want to do is put the barrel on. That's your starting point. Take your strippers and strip that back. Then separate the Kevlar from the fiber. And then that soft acrylite peel that Gary had mentioned, just peeling that off here. Now I take my cleaver, and for this connector, which is an SC connector, needs to be at 28 millimeters. You can see light's still on. Cleave it, light goes off. Now I've got my good connection. I take my connector and I line this up and I slide it in. You can see in that window there's a little bit of light. I push forward till that light's out. I lock this down, making sure to get that Kevlar in there for strain relief. And now, tighten that down, trim that off, put on the cover. There you go. In about 30 seconds, we're able to do a full connector. So much easier, much simpler, and a lot stronger. So with that, I'll turn it back over to you, Gary.